we are going to start a new Node.js project. So I am going to make a new directory, Node Streams Tutorial, and I'm going to open that up in VS Code. First, I'm going to show you what Node version I'm using. We're on version 20. Then I'm going to initialize a new Node project with npm init and the Y flag to answer all of the starter questions. Next, we're going to install our dependencies. We're only going to need two: NodeMon to help us develop our project and tsnode to help us execute TypeScript. npm install. These will be development dependencies, NodeMon and tsnode. Lastly, I'm going to create our entry point, which will just be an index.ts file. So touch index.ts. Fab. To help develop our project, I'll create a new script in our package JSON. So head over there, and then instead of this test script, we will have a develop script, and that is going to be a node one. We're going to watch index.ts for changes, and we're going to execute tsnode on that same file, like that. If we run this file, hello YouTube, npm run develop, we see our log. Great. So in this tutorial, we're going to be talking about how to copy files and use that as a way of introducing why streaming is useful. So I'll need a file to copy. We'll use something simple, just a text file. My file.txt. We'll paste something random in there. Okay, let's go. So first, I'm going to show you how to copy a file synchronously. This is the simplest, but it also has the biggest limitations. We will import the file system library from Node.js, function copy file, and then we're going to load all the data into memory synchronously. Const data equals fs read file sync. I'm going to read my file txt, and then we'll copy that file into another text file. Simple. Copy file, and then we can run npm run develop. And if you see in the file system on the left, we now have my file copy, and that looks good. So what's the problem with this approach? Well, it blocks the main thread, and JavaScript is single-threaded. So that prevents any other work from being carried out while the file is read and written. If it's a smaller file, this might be okay, but for a very large file, you don't want to block more important code from running. There are a few small use cases I could find for this. For example, it can be common to load SSL certificates synchronously during server startup, since these files are small and the process can be blocking. We could also use synchronous methods for developer scripts that run on a developer's computer, since then we might not need to worry about blocking the main thread or using up memory. But we can do better. One improvement on this approach is asynchronous operations, because they don't block the main thread. That means that the work to read and write the files can be done in the background. So let's adapt this function to be asynchronous. First, we need to put async at the top. Actually, before that, we'll import fs from the promises version of the library. And that gives us some versions of these functions that return promises, and therefore we can await them. So const data equals await fs read file, and similarly await fs write file. So if I go down into my terminal, let's delete my file copy, and then if we run the server again, success. This approach is applicable to a much wider number of use cases, but it's still not perfect because it's not suitable to cope with high volumes of data. When working with large files or more data that demands more memory, even this asynchronous method is flawed because it puts strain on our infrastructure. How do we mitigate these risks? Well, one way is to use streaming. Let's adapt the example into one that uses streams. So we'll go back to the normal fs library, First, we'll create a write stream that's going to write data into a location. Const write stream equals fs.create write stream, and we'll be going into my file copy.txt. Then we want to create a read stream to read from a source. So const read stream equals fs create read stream myfile.txt, and we're going to pipe the write stream so that what we're reading goes into what we're writing. Lastly, we can use the on event so that when the read stream has finished, we can also end the write stream. Read stream on finish, write stream end. Cool. So now if we restart our server and we look in my file copy, we have the text we were expecting. Let me just make sure I'm not cheating. So if I get rid of that, restart the server, go back, there's the text. Great. There's a slightly neater way of doing this, which is to use the stream library from Node. So I'll show you that now. If we import stream from Node stream, and we'll use the promises version, then instead of this pipe and this event, we can simply do await stream pipeline and insert the read stream in the write stream. So once again, we restart the server, there's our text. So far we've seen 3 ways of copying a file, but what if we want to generate a large amount of content, and how can streaming help us there? We're going to take a look at a simplified version of a real-life problem that I encountered in my work, which was generating a very large CSV file. A function that had been working for several months had stopped running, and it turned out the data that it had been processing had grown significantly, so it now required more memory than our cloud infrastructure allowed. First, let's see a non-streaming version of this problem. To start with, so we can see what memory we're using up, I'm going to create a function called logMemory. Memory contain. We want to log the RSS memory, and that's the portion of memory occupied by a process that is held in RAM, our main source of memory. The reason we're dividing by 1024 and 1024 is so that we can convert the unit into megabytes, which is going to be a little bit easier to read. Okay, let me re-import fs, and we're going to use the Node fs promises version of the library. And now I'm going to create a function which will write a CSV in memory. Async function write CSV in memory. For our CSV, we'll create an array of strings, const rows, which is a string array. We'll start with an empty array. To begin with, we'll push some headings. I want a number, and we'll find that number squared. Okay, and then let's create a very large amount of rows. So for let I equals 0, I think let's try 10 million rows. So we'll get a number, and then just so our computer does a bit more hard work, we'll square that number. At that point, we'll log the memory, and then we'll write to an output file, and we'll call this function. Okay, that's over 1,200 megabytes or 1.2 gigabytes, which is going to be far too high for most servers in the cloud. So the question is, can we get this memory down and solve this problem using streaming? I should add that I'm recording a video, I've got a lot of apps open on my computer, so the memory that we're going to be seeing is a rough estimate. But we can tell that the amount that you just saw was too high. So this is something that we want to optimize, especially if we're working on cloud infrastructure where our memory limits are lower. So let's see if we can solve this problem by using streams instead of bringing everything into memory. I will create a new write stream. And instead of pushing to rows, we will call write stream write number squared. And we've still got our loop, but instead of pushing to memory, we will write to the write stream. Keep our memory log here, and we will end the write stream once we've finished everything else. Now let's run this. Now that is taking up an even bigger chunk of memory, which is probably not what you're expecting. You came here to learn about improving your memory problems. We've implemented the solution and it's got even worse. So what's going on? The problem is a process called backpressure. Backpressure occurs when data is produced faster than it can be consumed. If a read stream or a data source, in our case, our JavaScript logic, sends the data faster than our write stream can process it, we end up building a backlog of data that's stored in memory. And so, as you can see in this example, we've ended up using even more memory than we did with a non-streaming method. How do we get around this? Well, we get around it by pausing writing data whenever the limit is reached, which occurs when the write method returns false instead of true. Then once the write method has drained, in other words, is caught up with the backlog, then we can continue writing data again. Backpressure may occur several times before we end our streams. So we need to add guardrails to our code to be able to cope with this scenario as many times as needed. Let's look at one way of handling backpressure in this example. And this time we're going to add some event callbacks to the write stream. So write stream on error. That's console error. Writing to the stream. Error. And on drain, which is when the backlog has been caught up with, then we will have a callback function that we'll write in a second called write data. And we can also write our first row. So write number squared. Let's delete all of this. And using hoisting, we can declare our function below here. Function write data. So now the way I want to do this is I want to iterate a value outside of this function. So let's create current, set that equal to 0. And then in the function, we can have a constant of a max value, which will be 10 million. While current is less than max, we want to write to the write stream, and it's going to return a Boolean as to whether we need to continue or not. The const can continue, and we'll write the number and the number squared. Now, as Copilot has suggested, if this returns false, then we can't continue and we need to drain. But instead of returning, I'm going to just break the while loop. Then let's log the memory. We'll end the write stream, and we'll also break from the loop. And I want to put this increment right at the top. There's one last thing to do, which is to call write data for the first time. Okay. I've just run this function. As you can see, we've got a bunch of draining logs showing you just how often draining needs to occur. But you can see our memory usage has shot way down. It's only 200 now, so it's around a tenth of the memory usage before we handled draining. This is a massive saving, and you can probably see how this is going to help you keep memory costs much lower for these kinds of operations in cloud infrastructure. And just to prove that we have indeed generated this large CSV, let's go to output CSV, thinking about it, and there, 10 million rows and all those square numbers. And if you were trying to do a rigorous test, you'd want to do a lot more logs in a very different setup to the one that I've got. It's pretty clear that if we're seeing a tenth of the memory usage, this has been really effective. So let's now go back to our file copying example using what we've learnt, and let's see how we can adapt our streams for copying a file to also handle backpressure. So now I'm going to copy the output of my CSV into my file.txt. My computer's going to need to think about this one. And we will remove my copy and output.csv. So how can we copy a very large file while also handling backpressure to keep our memory as low as possible? Let's create a new copy file function. And as we did towards the start of this video, we'll create a read stream file.csv, and we'll create a write stream. My file copy.csv. And in many ways, this is going to be a little bit easier than the more manual example we just did, because the read streams and the write streams have some handy methods that can help us out. So read stream on data. Every time we receive a chunk, let's attempt to write it to the write stream. And if we get false, then we'll pause the read stream. Now, when the write stream drains, we can resume the read stream and start it again. And finally, when the read stream ends, we can also end the write stream. And this would be a good point to check how much memory we're using. Finally, we're going to use the stream library, as I did earlier, to control the piping of the data. So we'll just import stream from node stream promises, and we'll await stream pipeline, and our arguments will be the read stream and the write stream. So let's now call copy file, and we'll run the project. So again, really small amount of memory usage compared to the other examples. My file copy.csv is once again what we expect. So I'm going to leave it at there for now. I hope you found this video a useful introduction to working with streams in Node.js. I've found patterns like the ones we've discussed to be really useful in my work. For example, if you use AWS and you want to upload files to S3, consider using streaming to put less load on your server. There are libraries that help you do this, that make it really easy. And if you've got your own experience of streaming, I'd love to hear about it in the comments. Please let me know. Thanks very much for watching, and see you in the next one.